The last two examples are going to be sample sizes again. We're going to practice this. So example 7 says, Aspen Ski Resort is assessing interest in a multi-mountain pass. They want their proportion, we're using proportions, to estimate and be within 0.038 with an 80% confidence level. We have a pilot study of 160 skiers found that 0.5 were interested. Find the sample size needed. So let's list out all of the information that we have. We have that our error is 0.038. So we want an 80% confidence level. So we have 80% in the center. We have our proportion from the sample, our p hat, to be in the center. And then our error comes out in either direction. And it says we want to be within 0.038. So that's our error. Oops, I wrote that one backwards. Let me fix that. So we have our confidence level is 0.80 or 80%. Now we're told that we have a preliminary study. It says that our preliminary value, our proportion is 0.5. So in this case, we do know what our p-value is. It's 0.5. Let's see, what else do we have here? We need to find our z critical. So we need to figure out how many standard deviations do we come out this way if we want 80% in the middle, which means there's going to be 10% in each wing. There's 20% left over, but then when we split it between the two wings, there's 10% in each wing. So use GeoGebra to find out what that value is, what that cutoff is, so that you have 0.10 to the right in that right wing and 0.10 area under the curve to the left. Those two z values should be the same, just one should be positive and one should be negative. See if you get the same thing that I get. When I do it, I get 1.28 for my critical value, but you should check to make sure yourself that you know how to do that. When we're dealing with the proportion, our formula is z critical over e squared times p times q, or you can write the q as the complement of p, which is 1 minus p. Either way, it's the same thing. So my critical value is 1.28. I divide by my error, which is 0.038. I square that, and then I multiply by 0.5, and then 0.5 again because it's the complement. Q is the complement. And when we get that, and we round it to the nearest whole number going up, we got to round up, we're going to get 284. So we should have in this study, in our sample, 284 skiers in order to get an 80% confidence level with a margin of error of 0.038. Last example, a historical review of hurricane data on the Gulf Coast aimed to estimate the average rainfall from major hurricanes. Given a standard deviation of 3.2 inches and a margin of error of 0.35 inches, how many storms should be observed to be 99% confident in the estimate? Round the critical value to the nearest hundredth. So here's our picture. We want a 99% confidence interval. This is a mean. We're talking about averages, so our sample mean is going to be our point estimate. That's going to go in the middle. Then we know that we have a standard deviation of 3.2 inches. That was given here in the problem, and we want a margin of error of 0.35. So we want to be able to come out 0.35 to get our upper bound, and 0.35 to get our lower bound for the confidence interval. So here's our confidence interval. Here's the area under the curve. It doesn't look very symmetric because I don't have the best drawing skills, but I'm sure you guys can visualize this. Okay, now we have our wings over here. The area in our wings, since we have 99% in the middle, that means there's 1% left over, which means there's 0.5% in each wing. As a decimal, that would be 0.005. So to find your critical value, you want to find the cutoff so that in each wing, there's 0.5%. So you're going to put in for the probability area 0.005 and find those cutoffs for the standard deviation for that z-score. You should find, and you should do this to practice, you can pause the video, you should find that your z-critical is 2.58. We're told that the error is 0.35, and we have our standard deviation. So to find our sample size, we're going to take our z-critical times our standard deviation, divide by the error, and square all of it. To find the sample size, my z-critical is 2.58. I'm going to multiply that by my standard deviation, which is 3.2, divide by my error, which is 0.35, and I'm going to take all of that and I'm going to square it. When I do that and I round up to the nearest whole number, the answer should be 556. So we should have 556 observations in that sample. So to wrap up really quick, we moved from descriptive statistics to inferential statistics by introducing confidence intervals. We talked about how to interpret a confidence interval. We talked about how to find a point estimate and the margin of error and what those mean. And then we talked about finding a sample size that you need to meet a specific confidence level or margin of error. So remember, the more precision and the confidence that you want, the more data that you need.